Hello friends, my name is Vijay, and in this demo I'm presenting the AI Explainability 360 Toolkit. This is an open source library released by IBM Research to help explain AI models and their predictions. So let me go to the GitHub web link. So as most of you probably already know, a key limitation of AI models is that they are generally black box in nature and cannot meaningfully explain their inner workings or decisions to end users. So it becomes quite challenging for various users of an AI model to trust the decisions made by these models. So in this toolkit, we've essentially released a comprehensive set of explainability algorithms that can be used by different users of an AI model. For instance, some of these algorithms could be used to explain the data that is used to train the model itself. Some other algorithms can be used to provide global explanations, that is, the rules that the model applies on the data to arrive at decisions. And some others provide you with local explanations, essentially what the model has observed in a specific input data instance to make a decision. So if you'd like to download the toolkit, install it, the setup instructions are available here. It's actually quite simple. And if you want to read a technical paper about our toolkit, then you can browse through this archive paper. We also have a large collection of Python tutorial notebooks, which provide you both with industry use cases as well as simple examples of how each explainer could be explained, invoked using a model and a data set. And the demo that I'm actually going to go over in this video is essentially based on this particular, Python notebook tutorial. So I've already opened that here, and in order to go to the demo web page, you can go to the main page, the main GitHub link, and then click on this particular link. So I've also opened that up here. So, so if we go to the demo here, so this is a demo that showcases three explanation algorithms from AI X360, which are relevant to finance. So in this demo, we essentially train an AI model to determine if a customer should be given a home loan or not. And the data set that is used to train the model comes from the FICO explainable machine learning challenge. So if we take a look at this data set, it has 20 or so features which summarize the overall credit history of a customer. For instance, the external risk estimate. So this is a feature that tells the overall credit rating of a customer based on various credit bureaus in the US. Then, for example, the feature average min file. This gives us the total number of months that span the credit history of a customer. So it gives you an indication of the length of the relationship of a customer to a lending institution. Similarly, for instance, the net revolving fraction burden, this feature tells us the ratio of the credit borrowed by a customer versus his credit limit. Then, for example, this feature, months since most recent delinquent, tells us the number of months that have elapsed since the last time the customer made a late payment on their loan. So all of these features essentially indicate in one way or other if the customer is actually credit worthy or not. So what the AI model does is it uses all of these features to predict this label, that is the risk score, of whether a customer would eventually repay their loan in time as negotiated when they applied for their home loan. So, so if we take a look at the life cycle of this AI model, then it essentially interacts with three different personas. So let's take a look at the first persona, who is the data scientist. Now, the data scientist is essentially interested in mainly training the training the AI model correctly, so that the model does not pick up any spurious correlations in the data, and he'd like to verify if the logic learned by the model is correct or not. And so that he could discuss that logic with a domain expert or a model auditor, and also to make sure whether the model is making any unfair decisions based on features such as gender, race, and so on. So one of the explainers in AIX 360 is called as a generalized linear rule model. So this explainer essentially gives you a weighted combination of rules which jointly predict the score of a customer. So, for example, if you take a look at the FICO data set, then here are some of the rules that the model has actually learned. So, and each of these rules is actually sort of weighted by a coefficient. So if you do, like take a look at some of the rules, for instance, each variable can be used by multiple rules. So for example, let's say, the external risk estimate. So there is one rule here, and there's another rule here, which also uses external risk estimate. So in order to make the job of a data scientist even simpler, the explainer essentially outputs such graphs which explain how each feature impacts the final score of a customer. So for instance, the following rule has been learned. So the external risk estimate is larger than 0.75, and the score actually increases by 0.26. So such rules essentially shed light on the overall logic that the model has learned. And if the data scientist is satisfied with these rules, he goes ahead and then deploys the model, which is then going to be used by a loan officer to evaluate a loan application. Now, the loan officer is essentially interested in understanding how the AI model arrived at its decision and how that reasoning correlates with his domain knowledge. So, let's say, for example, Alice's loan has been approved. So, one of the algorithms in AIX 360 called as Protodash essentially provides case-based reasoning. So it picks up these other loan applicants, Mia, Kate, and Carla, from the training data set, whose applications are actually very similar to those of Alice's, and these customers actually paid their loan on time. So the loan officer can view the features in Alice's loan application and how similar they are to those of Mia, Kate, and Kala. And if he's satisfied by this case-based reasoning that, if, since Alice's features are very close to these other applicants who repaid their loan on time, then it's likely that Alice might also repay the loan on time. So if he's satisfied with this reasoning, then he goes ahead and then, communicates the decision to the to the end customer, the loan applicant. Now, if a loan applicant, their loan was accepted, typically they don't have any questions. But if the loan has been denied, then they typically want to know why their loan was denied, and more importantly, how they could improve their application and reapply in the future to be accepted. So one of the explainers in AIX 360 called a CEM essentially provides these contrastive explanations. So let's say, for example, if Julia's loan has been denied. So the algorithm essentially picks up these top features and shows the feature values which are not in the right range and how those feature values could have been changed in order for the loan to be approved. So for example, the consolidated risk marker or the external risk estimate feature, its current value is 77, but if its value had been 82, then the loan would be accepted. So the customer can use these explanations as hints so that they could reapply their reapply in the future by modifying their or improving their loan application. So those were the three different explainers which are available in AIX 360 for with regards to this particular demo. But there are also several other explainers, and you can take a look at those explainers by either browsing these industry use cases or by taking a look at any of these Python notebook tutorials which show you how each algorithm is invoked, and also notebooks related to these two explanation metrics which can be used to assess the quality of an explanation. So this particular website, the Bluemix website, also has other resources. For instance, if you'd like to track, other tutorials and demos we have given in the past, you can take a look at this particular page. If you'd like to join the community, then you can request an invitation from a sort of a Slack invitation from this particular link. Now, if you're an algorithm developer, and would like to sort of integrate any new algorithm, then you can take a look at this particular folder, AIX360 slash algorithms folder on the GitHub page, and you can browse through the code of other algorithms and see how you could integrate your algorithm. And then you'd have to create a pull request, and you could also probably discuss your plans over Slack. AIX 360 is now part of Linux Foundation for AI as well, and we are happy to receive maximum contributions from the open source community. So thanks a lot. I hope you enjoyed the presentation, and please feel free to sort of input your questions during the conference. Thank you very much.